Imagine stepping outside on a clear night and looking up at the stars. Some are unimaginably distant, but a few are much closer, our cosmic neighbors. In the southern sky, one of the brightest stars is actually a trio, Alpha Centauri, just over 4 light-years away. It's the closest star system to our own. Alpha Centauri has long captured our imagination, a place we dream of visiting, a fixture in both science fiction and scientific curiosity. But it's not a single star. It's a family, Alpha Centauri A and B, 2 sun-like stars orbiting each other, and Proxima Centauri, a faint red dwarf. Proxima is the closest star to us, but the bigger question has always been, do Alpha Centauri A and B have planets? For decades, astronomers searched for planets around these stars, but their brightness made it nearly impossible, like spotting a firefly next to a searchlight. We found planets around Proxima, but the main stars remained a mystery. Did their binary dance make planet formation impossible? No one knew. The silence from Alpha Centauri was frustrating, but humanity is persistent. We built better telescopes, learned new techniques, and finally, the James Webb Space Telescope gave us a new way to look. Webb sees in infrared, the light of heat, allowing us to spot even cold, faint objects. With this tool, we turned our gaze back to Alpha Centauri, ready to ask the old questions again. Could we finally find a planet next door? The stage was set for a discovery that could change everything. The search was on, and this time, we had the best eyes in the universe. Alpha Centauri was no longer just a distant light. It was a real place, waiting to reveal its secrets. The dream of finding another world so close to home was alive again. Our cosmic neighbor was about to become much more than a point of light in the sky. The universe was ready to answer, and we were ready to listen. The next chapter in our search for other worlds was about to begin. The question, are we truly alone, or is there another world right next door? With new technology and renewed hope, we set out to find out. The answer was closer than we ever imagined, and it all started with a faint glimmer in the darkness. The story didn't start with Webb, it began years earlier, with a faint signal from the ground. In 2019, astronomers using the Very Large Telescope in Chile spotted a tiny, ambiguous smudge near Alpha Centauri A. They called it C1, a faint heat source that shouldn't have been there. Was it a planet, dust, or just noise? No one could say for sure, but it was enough to spark curiosity and guide future searches. Ground-based telescopes struggle with Earth's turbulent atmosphere, blurring our view. To get a clearer picture, we needed to go to space. The James Webb Space Telescope, orbiting far from Earth, was the perfect tool. Its infrared vision could see the faint glow of objects hidden by starlight. The hint from 2019 became a target, a breadcrumb leading to a possible planet. Now, astronomers had a specific region to focus on. The search shifted from a blind hunt to a targeted investigation. The earlier observation, though uncertain, laid the groundwork for Webb's powerful eyes. The cosmos had whispered a secret, and we were ready to listen. With a new tool and a clear target, the search for a planet next door intensified. The faint echo from 2019 was about to become a clear voice. The universe had given us a clue, now it was time to follow it. The hunt for Alpha Centauri's hidden world was on. Finding a hidden world required more than just a powerful telescope. It needed innovation. The James Webb Space Telescope, with its massive golden mirror, was designed to see the faintest cosmic light, but Alpha Centauri A is blindingly bright, threatening to overwhelm Webb's sensitive detectors. The solution, a coronagraph, a tiny mask that blocks the star's core, revealing what's nearby. Webb's coronagraph, part of its MIRI instrument, allowed astronomers to block out the star's glare and hunt for faint planets. This wasn't easy. Webb wasn't built for such bright, close targets. The team had to develop new observation techniques and image processing methods. It was like performing surgery from a million miles away. But it worked. For the first time, we could directly image the heat from a planet next door. This leap in technology changed the game. Instead of inferring planets from wobbles or dimming, we could see them directly. Webb's triumph was a testament to human ingenuity. We had finally built the tools to see the unseeable. In August 2024, the moment arrived. Webb stared at Alpha Centauri A, its instruments working in perfect harmony. The star's glare was suppressed, and a faint point of light appeared. S1. S1 was more than 10,000 times dimmer than its star, but it was real. Calculations showed it was a gas giant, about the mass of Saturn. Not a rocky Earth, but a colossal world of gas and clouds. S1 orbited within the habitable zone, where temperatures could allow liquid water. This was a shock. Models said giant planets shouldn't survive in such a binary system. Yet here it was, defying expectations and challenging our theories. The discovery, published in a leading journal, electrified the scientific community. If confirmed, S1 would be the closest exoplanet ever directly imaged around a sun-like star. More than just another planet, S1 was a rule breaker, a new chapter in our exploration. Our nearest stellar neighbor was no longer empty. One detection isn't enough. A planet must move with its star. Astronomers scheduled follow-up Webb observations in early 2025, but S1 had vanished. At first this seemed like bad news, but it was actually the key. Simulations showed S1 was on a highly elliptical orbit. In August 2012, con Juno de 2024, it was far from its star and visible. By 2025, it had swung close, lost in the glare. The disappearance fit the model perfectly, a cosmic game of hide and seek. This wasn't a failure, but powerful confirmation. Now, astronomers could predict when S1 would reappear. New observations are scheduled for late 2025 and 2026. If S1 shows up where predicted, the case will be closed. We'll have confirmed a real planet orbiting Alpha Centauri A. The puzzle pieces were falling into place. A Saturn-mass gas giant in the habitable zone is profound. While S1 itself isn't habitable, its location matters. Gas giants often have moons. Some, like Europa and Enceladus, may harbor subsurface oceans. Imagine a large rocky moon orbiting S1, warmed by Alpha Centauri A. Such a moon could have liquid water, maybe even life. The discovery shifts our focus, not just Earth-like planets, but Earth-like moons. S1 could be a beacon for life, or a sign that Earth-like planets are rare here. Its gravity might have cleared out smaller worlds, making true Earth twins unlikely. Still, the possibility of habitable moons is breathtaking. This discovery broadens our view of where life might exist. The search for life is more complex and more exciting than ever. S1 may not be home, but it could point the way. Our definition of a habitable world just got bigger. This discovery opens a new chapter in our cosmic story. For millennia, we've wondered if we're alone. Now we've found a potential planetary system right next door. The next years are critical. Webb's follow-up observations could confirm S1. If so, the focus will shift to studying its atmosphere and searching for moons. New telescopes, like the Roman Space Telescope, will soon join the hunt. The universe is more complex and surprising than we imagined. The search for life is no longer just about finding Earth's twin. It's about moons, ocean worlds, and new possibilities. Every answer leads to more questions. Alpha Centauri is no longer just a point of light, it's a place of promise. The story of S1 is just beginning, and it belongs to all of us. The next chapter is waiting to be written.